All right, ladies and gentlemen, welcome to week one, day four of Hotel Platoon. So today we're going to be talking a little bit about Python. So Python is another programming language. It was created, I believe, back in the 90s. That is a object-oriented programming language. Let me just write this down. General stuff. So can everyone see my comments on the screen? Okay.
Yeah.
Okay, perfect. So Python is an object-oriented programming language. Can anyone tell me what that means or what they think that means?
Yeah, it's a language that surrounds around the manipulation of objects, which could be strings, it could be I guess it could be anything. But I guess that's just kind of reiterating that line of number three. I don't know.
Oh, that's a pretty good explanation, honestly. Um, yeah, for basically Python likes to create things is a good way of thinking about it. So you have you have your basic types like you have strings, lists, dictionaries, etc. But more than that, also have things like classes and functions. And we'll get into what classes and functions are more later on. But the main thing to realize about Python is that you can stack things together, which is what makes it a very special language. It also is a relatively easy and cuddly language to deal with because its syntax is a little bit simpler than other ones. So, for example, you guys have all coded in JavaScript now. So you've seen that JavaScript really likes brackets and semicolons. Python does not have those brackets in that way where you need them every second line, and it doesn't care about semicolons. The only syntactical things you need to keep in mind for Python really are matching your parentheses and hitting the space bar. That's it. So it's syntactically a little bit of a simpler language. Um, yeah, that's probably a pretty good overview. So we'll start off by talking about variables. All right, what is a variable in like simple terms? Anyone, what does a variable mean to you?
A character or word that holds a value.
Okay, that's one definition. Anyone else want to try one? And there's no right or wrong answer.
I always think of them as something that can, kind of like math variables. It's a, it holds a value, but it can also be changed, and it's a kind of a placeholder in a lot of cases.
Yeah. So it's basically it's sort of combine what you guys said. It's something that holds some value, and that value can be sometimes changed in most cases, or accessed, right? So an example of a variable is I'm just looking out my window right now and I see a tree. So an example of a good variable might be number of leaves. So let's say the number of leaves on this tree is 10. So number of leaves here is the variable. And as you see, if the nice thing about VS Code is if you like hover over something, it'll tell you what thing it is. As you see, number of leaves is very clearly a variable. And it says that it is a literal type, which we'll get into that later, but its value is 10. Now, there's also something else I should mention. Um, are you guys familiar with the ideas of camel case and snake case? Have you guys heard of these concepts before? All right, Joe, you're nodding along. Do you want to maybe tell us a little bit about what those are?
Camel case is basically what you have on the screen there for number 10. How it's like lowercase and the second and third words are uh the first letter is uppercase. Which is used for JavaScript, and I believe snake case is what's used for Python more, with the underscores.
Yep. So there's two conventional ways to write variables if you have more than one word. Because let's be honest, if I just wrote this is my variable, um, that looks absolutely terrible. So you want a way to break up the words in your variables. So that's where the camel case and snake case come in handy. Camel case breaks up words or phrases using capital letters. Snake case breaks them up using underscores. So yeah, exactly like you said, people usually will use camel case for JavaScript and usually will use snake case for Python. In general, I would say personally, I would say use whichever one you like more, but make sure to use it consistently. Like the one thing I do not want to see in a piece of code that you've written is like one variable in camel case and then one variable in snake case. Like don't do that. Pick one and stick with it. So like you said, camel case is going to be like JavaScript standard. Snake case is going to be Python standard, but you don't need to abide by that. If you think that camel case looks better, use that in Python. You can use that in your Python code. If you think snake case looks better, you can use it in JavaScript. But just stick with one. Don't use both in the same piece of code. So just to abide by snake case principle and to be a good instructor here, we'll use snake case for that number of leaves. So and the 10 here is going to be an integer, which is a whole number. Let's see, what other types of variables exist? Let's say this is integer. What other types of variables exist besides integers?
Float.
Floats. Okay, what's a float?
Float is basically a number in decimal with the decimal point.
Okay, yep, that's pretty good. Example of a float might be like temperature.
Or fractional number is what I'm, I guess, trying to say.
Yeah, that's a good one. That works too. But something with a decimal point. So if it's like 70.4 degrees outside, then anything with the point, it makes it a float. Those are, roughly speaking, your two ways to represent numbers. Is either going to be as a whole number or as a decimal. There are other ways that we can get into if you guys want to get more complicated, but for a Python 101 day, this is a pretty good place to leave. There are some other types of variables that we can talk about. So, let's see. We have characters. So a character is just going to be usually you use single quotes for a character. So that would be something like A or Y or the typing the number 9 or something like that. You just say like my character, and I'll just type a random one. But then we also have something called a string. So what is a string?
A string of characters, essentially.
It is a string of characters. So let's call this like let's say I like using the hello, and I should use or I should be using snake case. Hello world string. str is used as a short form for string most of the time. Hello world. This is a string. Now, we'll get to this in a couple of seconds when we start talking about lists, but a string is also in Python, importantly, a list of characters. Now, this will come in handy when we start learning about how to manipulate strings, which I believe we'll get to next week. But that's something good to keep in mind. We've got two more types of variables, and then we can start talking about doing stuff. So the first one that we're going to talk about is a Boolean. So a Boolean is just a true or false value. So an example might be like, is the weather nice? And I can tell you in Washington, D.C. right now, it's not great weather outside. It's like 50 degrees and yucky and rainy. So I'll say that is the weather nice is definitely false. You can also just short form your variable names too. So I could just say weather nice, and that's pretty much the same thing. Usually you want your variable names to be more descriptive than not. Like I do never ever want to see someone to make a variable name like this equals like testicle. What is AB2? No one knows. But what you could say instead of this, something like placeholder string are easier to understand. And also, when you're writing code later, like let's say that somewhere else somebody has a line of like, we'll make that AB2 again. We'll say like, if A, then AB2 plus equals string 4. Like, I have seen pieces of code written this way, where what is A? I don't know. What's AB2? I don't know. What's string 4? I don't know. Do I understand what this piece of code is doing? Absolutely not, because the variable names are unclear. So whenever you're writing variables, make sure that when you write the name of the variable, it actually describes what the variable is supposed to hold to some extent. You can also always add comments to describe the variable after you define it. So, like for example, if I were to make a better comment for this temperature variable, I could say that temperature 70.4, and we could say temperature outside in Fahrenheit. Something like that. Just so that when someone's reading through your code, or you're reading through your code, like 2 weeks later, and you go back and say, okay, now I see what I was thinking when I named this variable, etc. It also helps a lot with debugging. I'm a huge fan of commenting wherever possible to sort of break down your code more easily. All right, one more type of variable, and then we'll get to questions. So the last type of variable is a none type. What might that mean before we actually talk about it?
The variable's undefined. It's
Yep.
null.
Yes, it's none, null, or for our purposes right now, pretty much the same thing. So another way to think of it is as a placeholder. Excuse me. So let's say that, let's see. Let's say that I don't know what the temperature is outside right now, but I know that I'll get this information at some point. So if I just define the temperature outside as none, it doesn't have a set value yet. However, later on, what I could do is like, say something like 15 lines of code later, temperature equals 70.4. And then now we are setting the value of temperature as a float of 70.4. So none is very useful as a placeholder that will not break your code. Now, the one thing you cannot do is let's say instead of saying none, let's say I just left nothing there. I can't do that in Python. Now, if you mouse over this little error box, it says expected expression to the right of the equal sign. Can't leave an equal sign with nothing on the end of it. So if you want to set a placeholder value, none is a really great option. If you're using numbers, sometimes people will use 0 as a placeholder, but sometimes you might not want to do that. So none is generally a better option. Or if you want to use a string, usually people will use a blank string as their placeholder for a string. So it usually is either none for a number or a blank or an empty string for a string. Okay, that's pretty much a summary of the basic types of variables that we have in Python. Any questions about any of that before we get to lists?
I have a question, and I hope I don't confuse the class, but isn't there sometimes where these these variables are immutable, so you can reassign, but you can't change something like that?
Yes, so we will not talk about that for a while, mostly because that won't come into what we do for a couple of weeks. But you're completely correct. There are mutable and immutable variables. Mutable variables are where I can change their value. Like with temperature, I can change it from none to 70.4, just like that. Immutable variables or like constant variables are ones where you set the value and you can't change it. That is not really done very much in Python. That's used a lot more in Java or JavaScript or C for that matter. But we will end up talking about it later, but I wouldn't worry about it too much for right now. But the answer to your question is yes, that does exist. But for right now, all the variables that we are going to be dealing with, you can change, reassign at will. Any other questions? Okay, if not, let's start talking a little bit about lists. So lists in Python are the analog, roughly speaking, to a JavaScript array. So what is an array? Anyone other than Adam?
I mean, is it essentially a list of strings?
Well, we can't say that a
Or
list
not
is
always
an array where
strings,
an
I
array
guess,
is
but
also a list. That's a circular definition.
yeah, I guess you're right.
How about a collection of objects?
There we go. That works. Yeah. So I'll just say equals collection of objects. Yeah, I think that's pretty simple way to define the concept. Another way to think about it is it's not just a random collection of objects, but it is an ordered collection of objects. So what that means for us is just like in JavaScript, you have where you have an array index. In Python, we have a list index. So can anyone remind me in JavaScript, what is the index of the first element in a list?
0.
0. Okay. In Python, it's the exact same thing. All lists in Python are 0 indexed. So 0 index, which is a term that you'll see come up. Some languages have one indexed lists, aka they start at 1, versus Python and JavaScript. 0 index means the index of the first element in the list is 0. Let's see. We'll get to list operations later as in the course as well, but lists are a very versatile data type in Python. Like you will see them show up literally everywhere. So learning how to manipulate them, which again we'll do not this week, but probably in next week or the week after, is very important. So the way that we define a list in Python, you just call this like my list. You define it using square brackets. And then you can put your elements in however you want. So you can have lists that are composed of numbers. So let's say 12, 4. I can just keep doing this. Or I can have, a second list that has characters. So I'm just typing random things on my keyboard right now. But this sort of goes back to the point that I made a little bit earlier about a string being a list of characters. So let's copy, but I'm going to bring this down here since we are talking about lists. So I've defined that hello world string is a string hello world. I can alternatively rewrite this as, type it again, hello world string, H-E L, okay, I'm just going to take out the world because I don't want to type that much this morning. L, L, O. So this expression and this string are fundamentally the exact same thing. Now, what does this mean for us? So let's say that I wanted to access the third character in the hello world string. How would I do that? Any ideas? Talk me through it.
Wouldn't you have to split that string?
So that's part of the fun of this. So because a string in Python is natively a list of characters, you wouldn't have to split it. So you can access, and so this guy and that guy are exactly the same. I'll rename this list.
Yeah. You're going to type in hello world list with a with the bracket and then the index number for which the third string, which is going to be 2.
2, perfect. That's what I was going to ask. So whenever you want to think about the nth thing in a list, you're going to access it by typing in the n-1 number. Again, going back to it being 0 index. The first item in the list is index 0. Second item in the list is index 1, and so on. So this is how we can access a item in a list is by using, again, the bracket notation, as Cisco mentioned. And we can also print this out using the print function. So whenever we run a function in Python, notation for that is going to be function name, and then stuff inside, or I guess we can call it function inputs. We'll get to writing functions a little bit more. See if I don't think it's in our, yeah, we aren't going to talk about how to write functions today. That's another next week topic. But print is a function, for example. So here, what I'm saying to Python is, hey, I want to take whatever thing is inside the parentheses and spit it out on the console. And if I hit the run button at the top right, see here that it prints out an L. And if I look back in my list, we have the third character is 1, 2, 3. That is an L. So that piece of code works. Now, what I want to demonstrate is that strings and lists strings are a type of list. So hypothetically speaking, if strings are a type of list, I should be able to access a character in a string the exact same way that I can access an element in a list. So the way I can check that is I can type in hello world string 2 instead of list, right? Where again, the string here is supposed to be a string. So if my theory is correct, then it should go HEL and then print out the L at the end as well. So let's double check that and see if that works. When we see that indeed, I can access the L in the string the exact same way that I did it in the list. So does that overall concept make sense of strings being lists of characters? Does that make sense? Any questions about that?
Yeah, I'm having like a noob question here. Can you do that in JavaScript? Because I thought we had to break it out like into if we had a string, we had to break it out in order to access a specific like spot within a string.
Like
Uh,
splitting the string?
yeah, splitting the string. That's exactly what I'm trying to get to.
Yeah, in JavaScript, I believe you do need to split your strings in order to
Okay.
manipulate the elements, which in my opinion, I'm a far bigger fan of Python than JavaScript. It's way more versatile. But this is sort of one example that demonstrates how it is.
Yeah. I was just curious because I thought every time I had to split it, and I was like, man, was I screwing up here? So sorry that kind of derailed this, but it's
Yeah,
just
you're good. I mean, part of the usefulness of talking through this is actually like comparing and contrasting the JavaScript approaches to Python. We're actually correction. Let me just double check this. No, actually, in JavaScript, you can do the same thing where you access a character in a string using like the square brackets. like in a list. However, I will say most of the time people end up splitting the strings. Why? Not sure. But usually, like in Python, you don't have to split the string. In JavaScript, you also don't have to, but people will do it anyway. Does that kind of make sense? It's sort of more of like a convention sort of thing.
Yeah, definitely. Thanks.
Yeah, no problem. Any other questions about this or comparing to JavaScript or things like that?
Yeah, I just want to touch on you can do the exact same thing with the array in JavaScript, just as you have it written out there. Yeah, splitting it out beforehand is making it more complicated, going about it a more complicated way. But yeah, you can do it simply by doing console log hello world list brackets two, and it'll give you the same thing.
Got it. I like to overcomplicate things, obviously.
It happens, trust me. It'll, especially once we start getting into algorithm design, that can be a very powerful tool. Or
Yeah.
sometimes send you down rabbit holes for 3 hours and then you realize you spent 3 hours doing it. But that's a problem for the homework. And I'm, as somebody who also suffers from liking to overcomplicate problems, 100% sympathize. That's part of the fun.
And Umar, I also want to touch on just to kind of connect the dots from our last class. Uh, so when you have function name and function inputs, I think most of my peers will probably be uh, it'll make it more easier if we call it arguments or parameters for that, instead of function input. So uh, yeah, there you go.
That's a good point. Thank you for mentioning that. But yeah, so I mean, you guys are familiar with the notion of functions being like black boxes where you put in inputs or arguments or parameters, which are all the same thing, and then you generate an output. Exact same principle here. Any other questions, comments, concerns, things like that before we move on to talking about dictionaries?
Well, I don't think it's an appropriate question at this point, but I know I'm going to forget it. I'm probably going to write it down. So hopefully I have some time with you afterwards. But like things are constantly popping up, and I'm like trying to restrain myself so I don't take us off course here. But just really quickly, like when right here you have a run button and it shows in the terminal,
Yes.
but I believe with JavaScript we were using some type of node to get it to print in the
Yes.
terminal. So maybe we could talk about that later. I mean, I don't think it's appropriate now, but that's just something like that I'm thinking about.
Sure, yeah, we definitely can. But what I'll say is that so in JavaScript, you end up having to do like a node and then like file, name of file.js, something like that, right? In order to get it to run.
Yeah.
So that is the equivalent of how we have to get something to run in Python. So in Python, there's the cheap way of running it, which is hit the run button. The other option is you can just say Python and then the name of your file. Oh, okay, fine. Python 3. There we go. So those two, this is basically when I hit this run button in VS Code, this is kind of telling the console to run this command, but do I want to type out the whole command or hit the run button? Rather hit the run button if I can. But in general, whenever you have a file of a specific type, like especially for things like Python, JavaScript, C, Java, or other languages, and you're trying to run them via the console, you generally will do that by typing in like the name of the language or an interpreter first, like Python 3 or Node, and then the name of the file. So that's a standard syntactical way to do it. Just for purposes of consistency, I will stop using the run button and you go back to using the Python 3 notation in there. But that's the exactly equivalent to using node in the JavaScript terminal, or in the terminal to run a JavaScript file.
And JavaScript doesn't have a run button.
Don't believe it does, but let's see. We can.
So Art, yes. So you can set up your IDE to run any type of language from the run button. But you have to make sure that you have your IDE set up to um, to access that run button for whatever programming language you're writing in. So and it's just best to get an understanding of doing it by the command line first, because you just want to get that brain muscle, that muscle memory going, right? And once you're more familiar with how to run it through the command line, you get a better understanding of what the run button is doing for you when later on down the line set up your IDE to work with different languages. So it's just the run button is just a, um, a GUI tool for your IDE. That's all it is, but it's essentially running the same command that you're running in the command line.
Great explanation, Cisco. I couldn't have done a better job myself. So thank you for that. Any other questions before we move on to the last couple items? And yes, as Nicole mentioned, yeah, the run button is an extension that you can install. Also, if you want to, you can also install extensions in VS Code, which you can do by going to not source control, extensions down here. And you can see I've got one extension installed for Python. You can do the same thing for JavaScript, which helps you a little bit with debugging, format, and things like that. Highly recommend installing the one for Python and JavaScript. And there's a couple of others that I can send along after for you guys to install that do things like bracket matching, which is a very, very helpful tool. But back over to the Python. Got a couple last topics, but these are things that you guys should hopefully be familiar with from JavaScript. So we won't need the console anymore. Let's talk about dictionaries. What is a dictionary? Anyone who hasn't spoken, or actually, here, I'm going to call on folks, because there's a couple I haven't heard from too much today. So, Nicole, would you mind telling me what a dictionary is?
From what I understand, a dictionary is similar to an object in JavaScript where you name it and then you can put keys and define them.
Yes. So a dictionary is essentially an object containing key value pairs. That's what makes it distinct from an array or a list. So as we said above, a list is an ordered just like collection of objects that don't have necessarily any relation to each other. A dictionary, meanwhile, has like keys and values, keys and values, keys and values like the whole way. So the way that we define a dictionary in Python, let's call this like a user dictionary, is we're going to use curly brackets. And then whenever we define a key, the key is always going to be a string, and the value can be anything. So we could say like that the user's name is going to be Nicole as a string. We could say something like student ID, and then we could type numbers. No, and this should be a colon, not an equal sign. And let's just add in one other thing. Wearing hat, and that is going to be true. So the other thing to note about dictionaries versus lists, in general, you don't want to include multiple data types in a list. Can you? Yes. Should you? In general, it's not really good practice to. In dictionaries, meanwhile, you are more than welcome to include different data types. So for example, here I have a string, a integer, and a Boolean, all in the same dictionary object. So dictionaries are great for us to store information about something. For example, this lets us get, again, Nicole's name, ID, and whether she's wearing a hat or not. The other option to storing this data would have been something like I could define username is Nicole, user student ID is this, user wearing hat is true. So the lines 57 through 59 and 51 through 55 functionally do the same thing, storing data of different types. However, by putting all of this into a single dictionary, I am introducing the concept of a relationship between each of these three items. These are all kind of like parts of a whole, if you will. Whereas down below, I'm just defining three random variables. These things aren't related to each other. They're just random variables that have random values. So how can I access a specific element of a dictionary? We do this using the exact same syntax as accessing something from a list. So with our list, if you'll remember, we access it using name of the list and then the index. In a dictionary, we don't have indices. So actually, let me just mention here. So we have list name and then bracket and then list index in order to get your element. For a dictionary, we're going to have dictionary name and then dictionary key. So if I wanted to get Nicole's name, which granted I already know it, but still, we could do so print and stop the pop-up. So user dict and then bracket. As you see here, VS Code is giving me three suggestions for what I want. It could be name, student ID, or where and how. Importantly, when you type in the key, you need to make sure that the key uses quotation marks because the key in your dictionary is a string. So just to make sure this works, we'll print out user dict name. And where is my console? Okay. Oh, I need to zoom out to find the fun. There we go. View. Okay, terminal. There we go. New terminal. There we go. Perfect. And we'll just do the same thing. Python 3, week 1, day 4, py. And we see that our code successfully runs, and we've printed out that the key name in user dict is Nicole. Does that make sense? Any questions about Python dictionaries? All right, so I'm just going to do a quick comprehension question here. Let's see. Who have I not heard from in a minute? Let's see. Adam. So I have 10 students, each of whom has a GPA. How would I store that data in Python? In your opinion?
You could make a dictionary where the keys are the students' names, and then you could assign those values with colons to each student, and you could call on that using a print statement.
Okay, that's one way to do it. Anyone else have a different way that we could do it?
Yes. Well, you just adding on to what Adam said, you also want to add a key with the GPA score along with it. So you got the student name and then the GPA.
Yep. So that's kind of the same principle of using a dictionary. However, could we also use a list to do the same thing?
Yeah, you could. I would think the dictionary would be easier to grab, but you could make a list.
Yeah. So there isn't a right or wrong answer in this specific case. If let's say that if you wanted to pull the value of a if you wanted to pull the value of a student of a student's GPA via their name, it's probably easier to use the dictionary approach. If you want to pull the value of a student's GPA by their student ID, which is, probably some very long number, it's also probably easier to do that using the dictionary approach. However, if it's just student 1, student 2, student 3, or student 0, student 1, student 2, student 10, and you just want to find, let's say, the average GPA of the 10 random students who we don't care about who they are individually, we could just put them in a list and then just sum the list and take their average. So dictionaries and lists are not the same thing. They are similar data types, but they're not identical. But when thinking about how you want to tackle a problem, like some of the ones that you'll have for homework, it's always important to think about what data type you want to use for your variables. And there isn't well, in some cases, there is a right or wrong answer. Like, if you have somebody saying hello world, you can't represent that as an integer. Or you can, but please don't. That would be absolutely terrible. But for things like, okay, do I want to use a dictionary or a list? Whichever one you decide will affect how you code the rest of them. So thinking about data types is super important. Okay. Let's see. So we talked about dictionaries, we've talked about lists, we've talked I don't think we need to talk too much about arithmetic operators. You guys know what plus, minus, and division signs are. One thing to mention that's not important for today's homework, but it's good to know in general, if you need to take something to a power in Python. So powers of numbers. So let's say I want to take 10 squared, which is 100. So we could say 10, you don't use the caret to represent a power in Python. Instead, you're going to use 2 multiplication signs to represent raising something to a power. That's something that when I first learned Python, got me really confused. So I always think it's important to mention. Will you ever really use powers when working in Python for most of the stuff we do on a daily basis? No. Well, might you use it at some point? Yes. So it's good to know. Another thing. Oh yeah. All right. Go ahead.
Would you mind showing a list of the same items that you had in dictionary, just so I can compare the list to the dictionary and see how that looks?
Sure. So that's a really good point actually. Let's do like list versus dict. So let's do that GPA example. We can say like student GPA gonna be like 4, 3.5, 3, 2.8. I'll just do 4 for now. And we could now also do this as student GPA dictionary. And then that becomes something like Joe with 4, have Bob with 3.5, Anne with 3, Chuck with 2.8. So these two are fundamentally representing the same data or almost the same data. Oh, Joe, I did not. Okay, well, we can change this to Josh. I'm assuming that
I'm
Josh.
just messing with you, man.
Well, I mean, well, hey, hopefully if you have a 4, I mean, that's great. You know, but so these two are fundamentally representing almost the same data, not identical, because the one thing you'll note in the list is that in the list case, you don't have the names of the students, right? So here, if I wanted to get, what I could do is I could, using this list, I could say, answer the question, get me the GPA of the second student, right? Because in order to do that, then I'd just say student GPA 1, where 1 is referencing this index. However, using the dictionary, I can say, get me and GPA, like specific, calling out the person, the key. And then that would be student GPA dict. And does that kind of make sense with the contrast?
Yes. Yeah. I wasn't getting the question initially when you were saying how can we do it with an array as well, so or a list as well. So yeah.
Would you need a second array or a second list to kind of coincide with the student GPA to kind of get the same information that you had in dictionary?
You could definitely do that. And I will say sometimes people will do this where they'll have two lists that have information that corresponds to each other where the indices match up. So like in this case, the index 0 for both lists is Josh and GPA. And that is definitely an option that you can use. People have done that. Personally, if you're in a scenario where you have two lists that the indices match up, it's just so much easier to put them in a dictionary. Also, because you can go from a dictionary to a list. So for example, where are my print statements? I'm just going to take out my print statements for now. So remember how we talked about keys and values? Well, in Python, I can get all of the keys of my dictionary as their own separate list. So let's say I wanted to say, get me all of the names of the students in my dictionary. So this phrase is the equivalent of asking for student names, right? Now, we don't need to reference student names for that. Instead, here I'm going to use a print statement. So I can go to student GPA dict dot. If we go down here, you see keys. So I do dot keys and run this function. This will give me all of the keys in the dictionary. So ideally, assuming nothing breaks, it should return Josh, Bob, Ann, and Chuck as a list. So if we run this, see here, well, I guess we should have done a to list, but returns all of the keys in a list style format. So that's another nice way that you can get the keys of your dictionary, if that helps. So there's also a way to do it in reverse, which again, we'll talk about later, not for a little while, where if you have two lists, you can zip them or combine them together into a dictionary, but that's a little bit outside of our scope right now. But does that help answer the question of, superiority of data types or which one to use for a particular application?
Yeah, that was a perfect explanation. And in order to tell you the truth, when I started this course, this is the type of instruction that I was hoping for. And up to yet, I haven't really got that. So this is a refreshing change.
Well, I'm glad to hear it. That's what we try to do. So anyone else have questions, want to see another example, things like that before we keep moving on? Okay. Oh, I'm going to just double check the curriculum page so that way when Jordan inevitably reviews the lectures, he isn't going to get upset at me for not covering something that's kind of critical. So, all right, we talked about fundamentals, talked about what Python is, talked about snake case versus camel case. We talked about variables and how those are, basically things that can hold value and things that can change their values. We talked about printing, where printing is the equivalent of the JavaScript console log. You put whatever you want to print inside of the parentheses. Super simple. We talked about our different data types. We talked about integers and floats, which are for numbers. We talked about characters. We talked about strings, which, as we demonstrated, are a list of characters. And we talked about Booleans, which are, your true false values. And we talked about none types, which are basically like null or generic placeholder values. We talked a little bit about lists and dictionaries. And we don't need to talk about arithmetic operators because, again, plus, minus, multiply, divide, you guys all know how to use those. Logic operators, we can touch on very briefly. So, of course, there's if-else statements, much like in JavaScript, that we have in Python. So, if you want to check if two things are equal, this is actually an important one. So in order to set something equal, so setting a value is going to be like my value equals 1. I'm going to use a singular equal sign. If I want to check if a value is equal to something, I'm going to use two equal signs. So it'll be something like my value double equals like 5. So this will return a true or false. This sets the value to 1. And the critical difference here is 1 equal sign is used to set the value. 2 equal signs is used to check the value. So in an if-else statement, let's say I wanted to say check if my value is 5, then do something. Let's say if my value equals 5, then, print stuff. If I did if my value equals 5 with a single equal sign, I'll get a syntax error. So make sure to keep that in mind when you're working with your conditional statements. Double equals to check, single equals to set. Cisco, yes, go ahead.
Yes, I also wanted to add that just to also connect the similarities with JavaScript. For Python, you only have to use the double equals for strict equality. Technically, there's no strict equality in Python, so double equals is as far as you will go, and you don't have to worry about the triple equal sign. Um, there is a typo on the lesson here under conditional logic. You'll see that there's actually a triple equal for one of the else statements at the bottom there. It's yeah.
Yeah, I see that. Thanks.
Yeah.
I'll correct that after.
Okay. Yeah. So that I just wanted to clear that up for people.
Thank you for catching that. Yeah, I'll go through and edit that once we wrap up lecture here. Yeah, any other questions about what I just mentioned? Also, one other fun thing that Python lets you do, unlike in JavaScript, is you can have if, else if, else if, else if, else blocks. So normally what people will do is they'll say, if condition equals value, then do stuff. This is very bad pseudocoding. So you'll see a bunch of syntax errors. And then you'll see like an else, and then if other condition, and keep going like that. Python gives you an easy way to do things. And I'm going to write this properly. So that way we don't see a bunch of syntax errors. If my value is 5, print hello. So instead of doing else if my value is 3, print goodbye. Instead of doing that, I could put the else and if on the same line. Or, more specifically, I can write an elif, which is a condensed way of saying else if. Now, one thing you want to keep in mind in general when writing if else or if elif statements, you can also just continue to cascade and to add more elifs. You can say something like if my value is less than 2, and then print could do nothing. You almost always want to end with an else statement, like just a generic else that will happen if none of your conditions are satisfied. You can say something like print exit condition. Is it required to end with an else statement? No. Is it good practice to? Yes. So let's say, for example, that you have a scenario where you need to print a value, let's say only print hello if my value is 10. So that part's pretty simple. You can say if my value equals 10, print hello. In this case, I don't necessarily need an else statement because I'm not doing it. However, it's good practice to still add an else statement. So we add an else statement, but I don't need to do anything if I don't, I mean, in my problem statement here, it says, just do something if my value is 10. I don't need to do anything if my value is not 10. But if I keep it blank, well, now I get a syntax error. So the way that we can bypass that syntax error is by adding this phrase called pass, where pass basically tells Python, hey, just do nothing for a little bit. So what this piece of code says is only print hello if my value is 10, and then sort of under that, if my value is not 10, do nothing. So pass statements are a really good way in Python to, number one, provide a placeholder. Let's say you're writing a piece of code that has like 4 different if statements. You need to break out each one individual. You can write one out and then put pass in the others. So that way you don't for testing purposes. Or then like in this case, if there's a case where you don't need to do something, pass is super helpful. There's 2 more little pieces, and then we will finally wrap up this gargantuan lecture, and I can get to answering some more of your guys' questions. So first thing we're going to talk about are functions, which I think Cisco already alluded to before. You have your arguments / parameters. They go into your function. They generate outputs. So in Python, remember when we define a variable, we don't need to say like const or define or anything like that. When we define a function, the way that we distinguish a function from a variable in its definition is we will say def, which is basically a short form for defining a function. We'll call it function name. And then we'll say function argument, colon, and then we will do stuff here. Let's just say, I don't know, we'll print a function argument, and then we'll print like 3 exclamation marks. And then lastly, it's always good practice to have your functions return something. That's how you wrap up a function. After the return block, your function is done. So signals end of function. Now you'll notice here, I'm not returning anything. I'm just saying return. You can also return a value, or you can return a variable. So with return, you can return nothing, you can return a value or a variable. That's either one is completely fine. That'll depend on what you want to do. So for example, let's say here I wanted to return hello world or something like that. If I were to run this function now, we can run a function again by doing function name and then put in your argument. And we can just say that this is like testing this function. If I were to just run this function right now, we see here that it does indeed print out our function argument, and then it prints out our 3 exclamation marks. However, it does not print out the return value of the function. The return value of the function is not something that gets printed. However, because we didn't tell it to print this value. However, what we could do is I could instead say that I want to print the function. When I say I want to print the function, that means I'm going to run the function, which is going to run these 2 print statements, but I'm also going to print out the output of the function, or hello world, which is what's returned. So if I run this now, by adding that print statement outside it, we are also printing out the return value of the function, which is hello world. Does that make sense?
Yes.
Perfect. So again, functions are something that are really critical because almost everything we do in Python going forward is going to deal with functions or conditionals in some form. See, I'm just double checking. Okay, yeah, the last thing we should probably talk about are loops in Python. So here, let's comment that out. Also, I know I've been doing this a bunch so far. When you make comments in Python, it's going to be hashtags. Now, there's 2 ways to make comments. Number 1 is the boring way, which is where you hit Shift and then 3, and you add the hashtag. The cooler way to do it in VS Code is on Windows at least, you can type control and then a control and then a forward slash. And that will immediately comment or uncomment whatever line you're on. On Mac, I don't use Macs, but I'm pretty sure on Mac it's either going to be control or command. You'll have to check which.
Yes, command. Yep.
Command. Okay. So we'll say control or command. But it's a super handy little shortcut that I highly recommend you guys use. All right. Last but not least, we're going to talk about loops, and then I can stop talking for the morning, kind of. So there's two types of loops. You have your for loops and your while loops. Real quick, anyone want to break down the difference between a for loop and a while loop for me?
A while loop is for when you don't know how many times you are going to iterate, and a for loop is for when you know.
That's actually a pretty good way of breaking it down. I like that. When you know how many times to run the loop. A better way to think of a while loop is run something until condition is satisfied. So it's similar to saying you don't know how many times, except you can actually set a while loop to run for a specific number of times. But that is, if you're interested in that, we can talk about that later. It's pretty simple. But let's talk about a while loop first. Or let's talk about for loops first, because I like using for loops a lot more than while loops. And I'll talk about why in a second. So in Python, when you have a for loop, you make your for loops based on a range. So what I can say is, let's say I can say for I is my little like index for my loop in range. And let's just pause for a second and read through the definition of range. So it says here that first off is what is range? Range is a function that generates an object. It basically creates a list of integers going from your start value to your stop value. And as it says here, the start defaults to 0 and stop is omitted. So range of 4 produces the indices 0, 1, 2, and 3. Now, where have we... Okay, well, it already says it right there. These are the valid indices for a list of 4 elements. So if I have a list, let's say if I want to run a loop 10 times, what do I want to put in range?
9.
Okay, why not?
Because it starts with 0, so you got, it's going to be 0 through 9, which are 10, which equals 10. Otherwise, it would be 1. It would be 10. So basically, it's 1 to 10.
Let's see what happens. So here we have, I want my loop to run 10 times. So I'm just going to tell it to print I, like to print the counter. So let's see what value it ends up getting printed. So it goes from 0 to 8. So if we mouse over that range function one more time and we read through it, it says that it produces going up to j minus 1, or it goes up to your stop minus 1. So that's why here it says for range 4, it goes up to 3. So but it produces 4 numbers. It starts at that 0 index. So if I want to run my loop 10 times, I need to do range of 10. However, we can make this a little bit more complicated. Let's say that I want my loop to, let's say that I have, where are my lists? Here, yeah, student names. So this thing has 1, 2, 3, 4 items in it. But let's say that I don't, if I wanted to print out every element of my student names, I could do print student names of I, so. All right, and again, range of 4, this is going to be 0 through 3, which matches up with the indices in student names. So if I run this, now see it prints out Josh, Bob, Ann, and Chuck, which are the 4 students that we have. Now let's say I don't want to include Josh for some reason. I only want to include Bob, Ann, and Chuck. We look at the range function and it says, apologies, very dry throat this morning. It says that we had also include a start, which is inclusive. Now, if I don't want to include Josh, remember that range of 4 is equivalent to saying range 0 to 4. So if I don't want Josh to be there, I just need to type a 1. And then we'll automatically skip Josh and just do Bob, Ann, and Chuck. And we try this and see that that works. So also note that your range will automatically increment by 1 every time. So let's say I didn't want it to increment by 1. Let's say that the only people who I wanted are Josh and Ann. Josh is a 0. Ann is a 2. Well, I want it to go from 0 to 2 and then to 4, but 4 isn't included. So I can set my step to be 2 instead of 1. So that way I'm skipping over every second thing. So if I type 0, 4, and 2, where 2 is my step, it should go Josh, no more Bob, and no more Chuck. Let's just double check that that works. Indeed, it does. So this is, again, somewhat similar to the syntax used in JavaScript for your sort of for loops, where you have the, let. This is the equivalent of saying for let I equals 0, I less than 4, I plus equals 2. Or I equals I plus 2. This guy and this guy are exactly the same thing. Which one's more condensed? Python form. Which one is, in my opinion, better? Python. Which one do you guys believe is better? You guys have a month and a half to figure out which language you like more. But you're stuck with dealing with both of them until the end of the course, so you might as well learn to like them both. Now, with while loops, and then we'll stop. While loops are really good to use if you have a condition. So, for example, what I could say is I can make a while loop that is based on something becoming true or false. Right? So I could say while whether nice is true, then I can do stuff inside this loop. I could say like, print whether nice today. Now, here's a problem. What if the weather nice never becomes false? What if it always stays true? My while loop is going to run forever. In Python, this is not the biggest problem. Your computer might just get a little bit annoyed at you. In other languages, like C or C++, or languages where memory really makes a difference, your computer will get very upset at you. And in Python, if you're running some complicated stuff in your while loop, Python will also get upset at you. So when you're working with a while loop, be very careful that at some point, your condition becomes false. If it doesn't become false, then you're going to be in some hot water. For example, a good way to make sure of that is, let's say that we have, let's call this a counter. Say my counter is 0. I can say while my counter is less than 5, then I can say like print I ate plus, and then we'll turn this into a string counter cookies today. So we should say I ate 0 cookies today, I ate 1 cookie today, I ate 2 cookies today, until I get to I ate 5 cookies today, and then it'll stop. Now, how many of you guys think this code will work and do what I want it to do, what I just said? All right, we have 1 vote. Everyone else looks really skeptical or tired of me talking.
Did you say won't work or will work?
Will work.
Oh, I don't think it'll work.
All right, that sucks. Cisco, why the skeptic?
Because you haven't incremented counter at all to ever reach 5.
Exactly. My condition is never going to break. So I'm not going to run this right now, but I will run this right before we end lecture so you guys can see what a runaway while loop looks like. But what I need to do is I need to say that counter is going to be incremented by 1 every time. If I don't do that, then counter just stays at 0 ad nauseum. But now it'll update every time I run this loop. We run the code. As we now see, it says I ate 0 cookies, 1, 2, 3, 4. Counter goes to 5, and I say stop when counter equals 5. So if we do not include this is the last little fun thing, and then we'll stop. And I'll make the console a lot bigger, and we'll clear it. That way you can see this happening. Now, I removed the counter plus equals 1 from that. I commented it out. So if we want to keep running this, I ate 0 cookies today, ad nauseum. And you can see that my computer is just continuing to run with it. Now, also, if this ever happens to you, and your code is just like running and you want to stop it, Control or Command C is the tool that you want to use. It's called a keyboard interrupt. And that's again, Control C on Windows, Command C on a Mac. So that's about it for Python 101. Any questions about any of the stuff we talked about today? All right, so let's stop the recording.